So in this video we'll be creating a reverse shell in the Rust language. So let's get started. We are going to import some packages from standard crate. So those are IP version 4 address and socket address version 4 and TCP listener, TCP stream and shutdown. And we'll be importing the command and exit from process to execute the commands and exit the process. So first we need to bind to the IP address and the port number. So what we're going to do is, first we need to create a IP address structure. So the parameters are 127 comma 0 comma 1. So this is how you create a IP address structure, but this is not we use it to read, right? So we can say let bind IP is equals to 127.0.0.1, and what we are going to do is we are going to parse this as IP version 4 address. So it will be very easy for us to actually read in this format. Let's cut here and let's say bind port is equals to 1234, and let's say IP is equals to bind IP dot, so paste here. So we are going to parse here. So we will get a result enum. So in this enum we will have two values, OK value or error value. If it's OK, then that means we will have this IP version 4 address structure. If we got error, that means we are unable to parse this IP address. So let's go and catch the error, match IP and OK of let's say I. So the success value will be thrown into this I, and if it's a success we are going to return this. Otherwise, if there is an error, we are going to print this one, println. So we are just printing the error and exiting out of this process. And we need to catch this one, we are returning here. So this is the return I. So let's say IP address. Now let's go and run this one. So let's say this random number, this is invalid IP address. So let's go and run this. We should see the error that the IP address is invalid, and we can see invalid IP address syntax. So this way we can handle each and every error. So that's where Rust gets shined. And next one is we need to create a socket. So socket new. So in this we need to pass this the IP address and the port number, that is bind underscore port. Let's also catch this, let's say CS, and we will get here. And we can also add another check if bind underscore port is less than 0 or bind underscore port greater than 65535. Then we are going to raise an error because there are only 65535 ports. So you can just copy this one. So copy this and exit. Instead of error we can say invalid port number. So let's go and run this one again. Let's remove this. Let's give some random value and explicitly define this as u32 just to raise this error. So let's go and run this. uh, so let's comment out this one and run this one, and we should see invalid port number. Of course, you will get error here because this we cannot create a socket out of the port that is out of 65535, so that's why we get error. Now we have created a socket. We need to start listening this one. You can say cs dot accept. Oh sorry, we need to we did not create this TCP listener. So TCP listener new, we need to, this one is listen I guess. Let's go and bind this to CS and we will get a listener. Sorry, we did not bind. Now we have binded and we get again result enum which contains the value and error. So again we can say match listener, and if OK of L, we are going to return that value. Otherwise, if there is any error, because we cannot bind to the port 80, we need administrator privileges, so that's why we get error sometimes. So we are going to print this one. We are going to print the error and exit out. So let listener, if there is any success, we will get this listener value, otherwise we are going to exit. Now we are good to go. So let's go and change this port number to 80 and let's see if we get any error or not. So finally, if there is no error, we can say drop of listener. So let's go and run this one. So I think this account is our administrator, so we did not get any error. But if you try to bind to the port under 1024 with a normal account, you will get error. So we got the listener. So accept, we are going to write one-to-one socket. So there is another method called incoming. So this will iterate over the incoming connections and give you an iterator. So you can pass that iterator to a function to handle that connection. So we are just writing one-to-one reversal. Let client socket. Okay, we will be getting two values, that is TCP stream and socket address. So we can say unwrap. So what we are going to do is we are going to say mut client socket comma client address. So we have got two items, client socket to interact with and the client address. Now we can say println client connected from, and the client have two IP addresses. One is its local IP and another one is remote IP. So client address dot local address. Sorry, the socket have the local address dot unwrap. So this will give you the client IP address and port number, and instead of this one you can say client socket dot peer address. So this will give you to which socket it has been connected. So in our case this is our server, so we don't want that, we just want the client address to print. So client address, so we have connected to the client has connected to us. Now we are going to ask the user to give the commands. So we can say loop let input is equals to let mut input is equals to, so we can throw the user input to this one new string. So we have created a new string and we are going to ask for the user input. So let's say print again enter command to send, and now we are going to use IO create stdin dot read underscore line. We did not import this one. We are going to pass this writable mutable borrow input, so this line will be thrown into the input. We can also say expect, if there is any error we can say string expected. Okay, we are good to go. We have received the command from the user, and what we are going to do is we are going to send this one. Before sending this we are going to throw a null byte at the end of the string, so we can do that using input dot push. So trust me, if you did not throw this null byte, it's gonna take so much time to figure out why we are getting the new lines and everything. And this character will act as a end of the string. So we have pushed the null byte to this one. Now we are going to say client socket dot write and ampersand. If you hover onto this write, it is taking the bytes. You can see U8 is a byte, so we can say ampersand input dot as bytes. Think we need to put this mutable borrow, so there are no errors I guess. So we have written the command to the client socket. Now we need to read the data from the client socket, from the client that have sent the output of the command. So we are going to create a buffer that is vector of U8. So this is a resizable array of bytes. So we can use something called buff reader. So this will gives us the method read until. So we need to wrap this client socket into the buff reader. So buff reader new ampersand client socket, and this will gives us a reader. So we can say reader dot read until. So we need to give the /0 here. So we are going to read the bytes until we face the null byte. Okay, so we need to say what. we need to also pass the array we want to store, that is ampersand mut buffer. So we are taking the mutable borrow because we want to write to that buffer. So we are good to go. So first we are taking the command and we are sending to the client, and we are reading the output from the client. So I think we are good to go. Now let's go and write the client command, so client program. So let's copy this, and I have already imported this execute cmd function, which will take the string size as a parameter and returns the output. So I had discussed this in the previous video. If you have not watched it, I highly recommend to watch that. Now we are going to connect using TCP stream. So I'm gonna just directly say 127.1.0.0.1.1.2.3.4. You can again match these errors. So let's say unwrap, again client dot peer address. So this peer address gives the remote server address we have connected to. Okay, so now we have connected. We go into the loop, and we can see the first thing we have did in the server is write. So that means we can easily say in the client side we need to read that data. So this is one very easy method to remember the operations. If here the first operation is write, then here it should be read. So we are going to create a similar buffer. So let's copy this one and paste here. So we have created buffer, and the client, so read until null byte. So we have got into this buffer. So we need to execute commands, right? So we can use execute command. We are going to pass let's say string from utf-8, and we are going to pass this buffer, and also we are going to trim this one, trim and match. We are going to trim the null byte out of this, because just previously recording of this video, I got an error if there is a null byte when we are passing to this function. So trim matches of /0. So these null bytes gets truncated, so it will be like a string slice we are sending. And let's say let output is equals to, so the output is the string output, and we are going to send this one client dot write output dot as bytes. Cannot borrow client as mutable. So okay, we need write operation, so we are making this client object as mutable. And also after we are getting the output, we need to push this null byte. So now I think we are good to go. Also we need to check if the command sent by the server is a empty or quit, then we are going to quit, right? So here we can write that condition if buffer dot length is equals to 0, or so copy this string is equals to quit. Then we are going to break the loop, and after breaking, what we are going to do is we are going to shut down this client dot shutdown, and shut down both ways. So we can say client socket dot shutdown, shut down both. So we can write a print here, shutting down the client address. And also, if input is equals to quit, then we are going to break this one. So I think we are good to go. So let's go and run this one. Let's put some print statements here. Binded to cs.ip, cs.port. Okay, so let's go and run this, and we should see the message binded to or bound to 1234. So let's go and run this one. Now we can send the commands. Who am I? Okay, we are not printing anything. Let's go and print this. Ampersand buffer dot trim. So we get any we can remove all the null bytes. In the account client, we can also say received from server. So let's go and run this, and who am I, and we can see the username. So we can also see the error, so we can also execute the PowerShell. And if I say quit, I should quit. Alright, so let's hope it will quit. Okay, the quit is also being understood as a command, I guess. So if I control C now, I should exit. So okay, that's all for the reversal interest. I also improved this program by handling multiple connections. So here there is a handed connection for every socket, and we are going to do the same. So we are going to same uh, sending the commands and receiving the output. So one thing will be changing is this listener dot incoming. So whatever the incoming connection, it will create a object iterator, and we are going to pass that into this handed connection. So you can implement the multi-threading here this for this function. So it will be like a multi-threading server. So that's all for this video, reverse shell in Rust language.